and please join fast. I think the most of people has joined. Okay, then we will continue with the session, the video. Here we'll see first about the red giants and white giants we have previously discussed in our presentation. This is how the three kinds of stars, very huge star and a medium star and there's very small star. This is how the red draft will be. This is we will see this is how the red draft will be exploding its outer layers, then which is forming to the white drafts. Means the red draft will releases its outer layers to the space. Then it is the core layer will be of white drafts, and we can expect the more lifespan on the red draft instead of having a sun as of a star. If we have a star like a
Video,
red draft, we can have a
sir,
more.
sir, video is not seeing, sir.
Yes,
Just
sir.
a minute.
Video is not opening.
So we can't see the video.
Yeah, okay, I will be. I think now is visible. I think so. Is it fine?
Yes, sir.
Yes, sir.
Yeah, here is our three kinds of stars we have previously discussed. What is the hottest star and the sun-like stars and the coolest stars. This is how the red draft will be with the fully of the lava surfaces, and it's a the helium is inside it. It will burn, and after the helium was completed, when the nuclear reaction has been stopped, then it explodes its outer layers to the space. You can see this is how the red draft's light will be when compared to our Milky Way galaxy. This is how the red drafts will be, and most of 35% of our Milky Way galaxy having of the red drafts, and the white drafts 70% of white drafts is having in our Milky Way galaxy. And this galactic flow in which is our middle of our Milky Way galaxy is also a huge red drafts. And this is how we are seeing in the video visuals how the red draft is releasing its outer layers to the space. This is how the red drafts will look when the light was being blurred. This is how the huge red giant will be. And it is also like our sun, it is rotate on its own axis, and its gravitational field will have the earth like planets too, but which is having a heavier heat over to its nearer planets. And this is how we're seeing this, how the radiation and magnetic fields will be for the red drafts also like our sun. Now coming to this white drafts, this is how the white draft will be. Means like the core layer of the red draft, it is called as white draft, and also the white giant. And this is how the mass of a white giant will be. This is how the red drafts and the white drafts is exploded. It outer layers to the sun is the presence, and it's the hydrogen and the helium, which is having its outer layers, which is exploded to the space. That's why the space is having a very much radiation, and the content of helium and hydrogen in a very huge amount. So that's why we are having a space suits to survive over there. But the tardigrades is which the animal which is survived with the bacteria which is survived without any protection things from our earth, the first species which is survived in the space. And this is how the combination of a two black holes means when the two black holes is combining. This is how the visual will be, which is having a tremendous amount of radiation and gravity inside it. Though, so the big one is going to take inside a small one, then it will be formed into a again like a supernova explosion, or either it will be blasted, means the radiation is released into space, or it is forming into a huge black hole. If the both black holes having the same massive structure, then it will be going to supernova explosion again. If the black hole one is having the smaller mass and one is having a huge mass, means like a stellar black hole and the supermassive black hole is combined, then it is going to form in more with a more gravity and more radiation is for going to form very huge black hole. If that having only the two small ones, then it is going to be a supernova explosion. And this is how the visual will be when the two black holes are combining. The black holes are not like our star in the space. They will be surviving on the space each every time. There is not like our galaxy. There will be, is not staying in a one place. The black holes are surviving on the space and every time, but it will be surviving slowly because of its gravitational field on the space. But the black holes are having very huge and tremendous amount of radiation, and also the heat, and also the very huge gravitational force. That's why it is taking everything into it like a huge vacuum cleaner in the space. And this is how the black holes will take everything into it and releasing on the another side of the space. This is the core layer of the black hole, which is having a tremendous amount of radiation and gravity taking inside it. Okay, fine thing. We'll move for the next presentation. Yes, in our next topic, we are going to, this is our last presentation. Now this is going to discuss about, just a minute, please. Yes, here we can discussing about how the where we can find the Earth-like planets. Those Earth-like planets are, so someone is in waiting room. Style hello them. Yes, I think now everyone is in the class. Okay, then we'll continue with now. Now we are going to discuss about, I'm going to discuss about the habitational zones. What is a habitational zones? Where we can find the Earth-like planets. Okay, I think the screen is sharing. Yes. Yes, here we can see this is how our this is we can see this is our sun. This is our sun, and where is a habitational zone? This is where the first layer from the star is of two hot zone. Where in our solar system we are having of two planets, where the Mercury and the Venus, which is having very two hot layer. So there is no content of water over there and no icy surface. So we cannot with any species from our Earth cannot survive in the too hot zone. And coming to the last layer, which is of too cool layer, which where there is only the content of the ice, there is no heat is gone to the third layer from our star, which is a habitational zone. And this is the just right thing. This is the second layer, which is having a green layer. You can see here it's a 1.2x from the Earth. This means only the Earth and Mars is going to be in this third layer, and the Mars is going to be in the middle of this layer. So that's why it is having, it's in upcoming, it is having to get the oxygen, and it is the atmosphere conditions are changing in the Mars in next 50 years, and it's getting the water on the Mars. Means it is getting now, it's there is a full icy, somewhat icy in the Mars. if there it is getting melted, then it will be formed into the water because of its nitrogen content on the Mars. It's getting in next 50 years, it's getting some watery surface at where the species can survive where without any water on the other planet we can't survive. So this is how the just watery surface, because of the heat is coming from the one side and the cool is coming from the another side, just right. So that's why this planet, the Earth, is of the midlest planet and which is of habitable zone, and it's a 1 to 2x from the Earth. This zone will be, and this is how we are having of a water on the Earth, and there where the species are surviving. And this is the third layer, only not only in our solar system, in every solar system in this universe, where the star, from the star, the third layer where the humans can survive. Only in the third layer the humans can survive, not only in our solar system, in each and every solar system in this universe we can survive on the third layers. Now we will see, is there any Earth-like planets where they are found, and now we'll see on the topics. Here you can see, this is first, if we, instead of going there, first we will see this one. This is how, the second, this is second layer, and there are three layers we have discussed: the two hot and medium temperatures and two cool. This is a habitational zone we are seeing, is this one. This is the graph of major habitational zone. And this is how the Earth will, where the Earth will be. This is how the habitational zone conventions, and the blue mark will be of from where we are watching in the graphs, it is of two cool layer. And this is how the sun, where the sun will be, and the temperature will be increasing when we are moving in towards the sun, and we are moving from far away from the sun. It's of two cool layer. That's why the Earth is having, the Earth also not very middle of the middle layer of our, from the, in our solar system, from the sun. It's also from somewhat middle from and front of the, means it is like after the Venus, right? So that's why it is of somewhat closer to the sun. And Mars is also, Mars is a somewhat uh, beside from the third layer. So that's why it is not having the water content over there, but the Earth is having the water, and temperature conditions are also very good. So that's why we are surviving on the Earth. Then next we will see about Earth-like planets. Does Earth-like planets exist? Yes, the Earth-like planets, and there are billions of Earth-like planets existing, and that was founded by the Kepler Telescope. And this is how the first picture we will seeing. This is how the Earth, and the same as the Earth, there's Kepler 62e. It was having the same content of oxygen, mostly of same content of oxygen and all other gases over there. And also the Kepler 62f, it's like a Mars, means but it's not take 50 years, it's take somewhat lesser than that. It will be getting like a Earth. And this is how the telescope, where this is the telescope only launched to find the Earth like planets. It's a Kepler telescope. And you can see here how the Kepler telescope finding its view, means it is targeting the graphs over here. Okay, someone is waiting. Yes, yes, yeah, you can, you know, there is a Kepler telescope, where the Kepler telescope is having a huge boxes, and like a graphs, it is taking the pictures and sending to the our International Space Station. From it is receiving from the Earth stations, where the scientists are getting taken of these photos, and scoping their lens towards that star, and they are finding the Earth-like planets in the third layer, which is a habitational zone. This is how the planets are found by the Kepler telescope. Okay, we'll see next slide. And this is how the Kepler telescope finds the many planets, the Earth-like planets, and found Earth-like planets. And near to our, and there is a very near to us, there is a one Earth-like planet, means like a same as a same oxygen and atmosphere conditions on that. It is called as Alpha Centauri galaxy. And this is how, sorry. Okay, this is Kepler was founded these many kinds of Earth-like planets. We are seeing now Proxima Centauri b and Galileo 667c, Wolf 1061c, Kepler 1229b, and this, and not only this, and there are many Earth-like planets are founded by the Kepler Telescope, but there is no way to get into there. But only now it seems we are going to Mars, and which is having a very big problem to us to carry the our fuel to Mars, and we are carrying the two rocket fuels with a which is filled with a full, which is one ship is filled with a full of rifle with full of fuel. Oh, means it's very possible, it's very impossible to get to the Earth like planets. In future it may be possible, I think, because of the SpaceX only, that too. And now we'll see about this Alpha Centauri. Why we are talking about Alpha Centauri in the sense here, the Alpha Centauri was the nearest to our solar system. It is having, but it's not like our solar system. It is having of 3 stars, and it is a triple star system, and which is a 4.3 light years away, and it is having of 2 stars, and it's a one is Alpha Centauri, and we named it as Alpha Centauri A, Alpha Centauri B, and the one star, these two, Alpha Centauri A and B, are rotating on their own axis, and like our sun, they are very closest stars to each other, and the somewhat distance from the these A and B, there is a Alpha Centauri C. It's also called as the Proxima Centauri, and which is the Proxima Centauri having a Earth-like planet, and which is our nearest Earth-like planet. In future, if we are having a trouble in our Earth, means our sun is going to die or any other reasons, we are has to go to the not only Mars from our solar system, we has to go to the Alpha Centauri galaxy only, because it's a very nearest, means like a 4.3 light years away from our sun. You can see here how nearest to our sun it was. Yes, here you can see, this is I think it is visible. Here you can see this is our sun, and this is our planets are rotating in these layers. This is the second light year, and this is the fourth light year, means the 4.3 light years away. This is how the Alpha Centauri A is located, and the Alpha Centauri B was located, and this is the Alpha Centauri C, means like a Proxima Centauri also called as and the Proxima Centauri is 4.1 light years away, means which is of near from the sun, instead of when compared with the solar Centauri A and Centauri B. And this is the fourth light year. This is how the light years are calculated, and this is how the distance we can see from the light years. This is how the space calculations will be when compared with the distance in the space. And now we'll see some atmospheric conditions. We can see from the Earth and Proxima Centauri B, it's not completely like Earth. There is an existence of water in very soon when compared with all other, means Mars, and we have seen the Kepler's telescope's Earth, and this is a very huge and same as like Earth, means the size is area is the same like Earth, but the Proxima Centauri is having a lava materials now. In future it is getting soon of water over there, but there is a existence of water, but we not find it over there big. But why, means we cannot went up to there now, means only we have our rockets only able to send to Mars only up to that extent, but not up to the Proxima Centauri B. If there is any possibility to send the telescope, not only telescopes, where now this is a picture taken from the telescope only, where if it is a possibility to send our rovers to the Proxima Centauri B, then where we can find how many is there any water content and gases present in the Proxima Centauri B, and this is how we can find enough by using our rovers. But we are not having that much kind of huge rockets on the to carry the fuel to the Proxima Centauri B, and we cannot go with our solar energy also, because the solar energy will end at our like after coming to our huge planet is Jupiter, where our solar energy will end over there. So we cannot go with our solar energy also to the Proxima Centauri b, and not only Proxima Centauri b to up to our Mars. We cannot exceed the Mars up to the Mars only with our solar energy, where it is going to lose the solar energy from the Mars after the Mars. So we have to make the rocket with having a light speed. If we have an right speed rockets, then we can move into the Proxima Centauri b, and where the SpaceX is working on that. This is how the atmospheric conditions that was picture taken with the telescope. Now this is when compared with our sun. We can see how the Alpha Centauri A and Alpha Centauri B, and this is how the second one is, this is how the sun will be, and this is how bigger than, it means one or two times bigger than our sun is Alpha Centauri A, and Centauri B of smaller, one time smaller than our sun. So Proxima Centauri B, A and B are rotating. Means if we assume that if we've taken the sun from here and they are rotating on its own axis, and all planets are rotating on this Alpha Centauri A and B. It's a two-star solar system, and this is how Sagittarius A, which is having another Earth-like planet, which is not very near to our solar system, and this was taken from the Kepler telescopes. Earth-like planets we have found it in the Sagittarius A solar system. This is how the size of Proxima Centauri B there, which is having Earth-like planet, and this is how the size of a Jupiter. Means you can see how the Proxima Centauri galaxy is same as the size of a Jupiter. Means we can assume how much smaller is the when compared with our these stars and to the Proxima Centauri B. And this is where we end our session, and we will watch the videos of this Proxima Centauri and Earth-like planets, which is founded by the Kepler Telescope. Just a moment, please. I'm going to share screen. Yes, here we go. I think it's visible the video now. Just please reply me. Okay, then I will share the screen. Just a moment, please. I think the video is not visible. Yes, I think now it's clear. Here you can see it's what is a habitational zone. I think now it's visible. Okay, something. This is how the Kepler telescope has founded the Earth-like planets. We have discussed about the habitational zone. This is how the habitational zone from the solar system. Here we can see this is how the solar system. This is how the top 10 Earth-like planets, which is means how the top is calculated means when according to its nearer from our solar system, and also the atmospheric conditions, which is Earth like Earth. There it is rated as a top first, second, then third, like that. These are some of the Earth-like planets. Here you can see this is how the watery surface is also existing. Coming to the aliens topic, there is a we can that's why we have having a session with tardigrades. There is a bacteria which is living in space, which from the Earth species. So like that, if there is in any other Earth-like planets, is there any species which is going to live in space? That was why the aliens topic has came to the scientists, and how means like how the Earth will be aliens will be existing or not. That is how the aliens will be living in outer space. That where the topic came from. This is the Kepler 62 system, which is found the same Earth-like planet in the 62F. The 62E is of clearly like a Earth, and 62F is like a Mars. Same in our like a third layer, which is having like our Earth and Mars in the another solar system. South Claria 66667 cc, which is found by the Kepler Telescope only. Is having a desert-like atmosphere, means this is having water content on the planet, and that's why it is taken as a top 10 Earth-like planets. And the view of from the outer space means of another planet is not like our sun. Here you can see this is how the stars will is having same like as our in the Alpha Centauri also having of 3 stars, and also our day timings and daylight timings. Then there will be also be changes, and also the for day 24 hours is, and the Alpha Centauri it's estimate in the Mars only it's estimated to be 48 hours atmospheric conditions and as a day. And also the gravity is also somewhat higher when compared with our Earth. And if we have a, for example, if we have a weight of 100 kgs in Earth, we can assume in a Mars is of 30 kgs only. And also our height will be increased because of the gravitational field on the Mars. These are the Earth-like planets. These are the centuries. Alpha Centauri is of 2 Alpha Centauris, as we have previously discussed. This is a Sun, Alpha Centauri A and Alpha Centauri B, from where the 2 light years, 4.3 light years away. That's what we have previously discussed about this Alpha Centauri from our Sun. This is the Proxima Centauri B, the Earth-like planet, what we have discussed, which is of very near to our solar system. This is how the Proxima Centauri habitation zone, what we are watching now, is orbiting of 0.05 AU, means AU in the sense which is red, means from the Alpha Centauri star, it is rotating on the 0.05, means like our same as the habitational zone like our Earth, it is rotating the oval shape only, means like our star. So for our star the planets are rotating same like as that. Proxima Centauri is also rotating in the from the Proxima Centauri A and B. This is how the atmospheric conditions that we have observed. And there is we can see this is of the red layers. Where red layers is of heat and temperature we can observe in the meter scale. In the Proxima Centauri B, this is how the atmospheric conditions we have watched from the IR. red layer which is of content of full of rusty materials, means like a helium and hydrogen combined, and this is where the water content on the like our Mars. You can see this is a hotty side and this is of cooly side from our from there. This is how the Proxima Centauri A heats, and Proxima Centauri C. Second is single 1 and single B, Proxima Centauri C. This is how the radiations will be from the Proxima Centauri A and B, which is going to receive with the Proxima Centauri C. From our galaxy, the Alpha Centauri stars are, there are two stars, but from our galaxy there is a view only like it's combined stars, but they are separated from our, from if we go nearer. Here we can see the Proxima Centauri B, same as like Earth's atmosphere and cloudy with our nitrogen and helium. Here we can see this is how the Proxima Centauri distance. From Earth to Proxima Centauri B is a 4.3 light years away. This is how the Proxima Centauri we have seen about. This is where we end our session. Okay, if any questions, just please make a chat box. I will be replying here. Just having any doubts, just chat in the chat box. I will be waiting. Thank you for having this Space Life internship, and your certificates will be sent to your mail IDs. And if you want to these any, if you want these any videos and presentations, just message to us, then we will sending. And also then YouTube, you can see as Space Life, where you can watch total of your videos. Can a Li-Fi be based on the deep space? No, up to now it is not possible, I think so, where I am not aware of this topic. Deepthi Ramesh, no, Li-Fi is not possible, I think so. Send also, yes,